Hi everybody, James here again. We're going to go over the information from class on Wednesday for your assignment. This is going to be a short one because it's Friday and I know everybody values their weekend. So we're going to go over measuring protein concentration, and most of this was covered, or all of this was covered in the lab section, so it's going to be short. Measuring concentration. So concentration is literally defined as the amount of substance in a defined space. That's the basics of it. So if you have an Epworth tube with more stuff in it, you're going to pass less light through that substance. It's that simple. And of course now the stuff's coming up because of the way that this slide was written. Oh well, we'll continue. DNA absorbs light at 260 nanometers. I hope you all know that by now at this point in your academic career. Proteins primarily absorb at 280 nanomolars. Nanometers. There is one exception to that. Pure DNA, the A260 to 280 is around a 1.8 ratio. I'm sure that you guys have been schooled on that in the previous classes. Pure protein, the ratio of 260 to 280, we're looking at a negative 0.55, which means that we've got zero DNA. So if we measure a 260 to 80 ratio on the spectrophotometer, it's typically not to, when we're looking at just A280, it's typically not to measure protein concentration, it's to measure the purity of it. Phenylalanine is the one amino acid residue that does not absorb at 280 nanometers. It absorbs at 257.5, so it crosses the peak with DNA. Hence one of the reasons we use reagents and regress a line off of our standard curve in order to measure the concentration of that. How do we measure absorbance? Well, we don't, not directly. We measure transmittance, and absorbance is calculated. Transmittance is log transformed into absorbance. And why do we do this? So here's our basic math for transmittance. I'm not going to spend a lot of time on this. You can look at the slides. I'm assuming that everybody has a base level education in algebra at this point. This is more of just a refresher for the rest of this course. And this is the meat of the matter right here. So why do we not use transmittance? Because transmittance, as seen on the left here, gives us a hyperbolic curve or an exponential curve, whichever way you want to state that. And on the right, what we've got is that curve that's been log transformed, and so we can plot a straight line. That's really why we do it, is because it's easier to measure on a straight line. Non-linear, linear. Yep, we already said that. And what things can impact absorbance? The number one thing that's going to impact absorbance is, well, two things are your concentration, which you see here on the top, a higher concentration, on the bottom, a lower concentration, and path length. The longer the path length, the difference in the amount of absorbance you'll be able to calculate. We don't have to worry about this so much with modern day equipment because we really can't adjust the path lengths in those. And when we get to using the nanodrop, the math is on the machine for you. So when we get to analyzing our protein samples here in the near future, the machine's going to do the math for you. And through the rest of your career, this is probably how it's going to go. So this is just a refresher to make sure that you know where all of this comes from, the theory behind all of it. And linear concentration. And this is just a reminder of the Beer-Lambert law. And what we're going to do here is this is just a demonstration of how that law relates to a straight line. So if you look here, we've got the different variables on the left for the Beer-Lambert law. On the right, we've got our line slope. Above that is the comparison, the direct comparison of where those variables fit into the line formula. Don't let this be too confusing. Again, this is just a refresher. And everything that is on the assignment was either covered in these slides or in the lab practicum on Wednesday. All right, you guys have a wonderful weekend, and I will see you on Monday.